A very good morning to all of you. Myself, Dr. Varun Narayan Mishra, and today I am going to discuss about unmanned aerial vehicles, which we know popularly as UAV. It's a very important recent technology in the field of urban planning, or you can say in the field of mapping of terrain, in the field of acquiring the data sets in inaccessible areas. So today's topic is about the types of UAVs, what are the applications and challenges in using unmanned aerial vehicle. So, as the name unmanned aerial vehicle is very clearly that it is an unmanned aerial vehicle. It is a kind of aircraft that carries no human pilot or the passengers. Okay, and you have heard the name drone. Okay, so drones are one of the most popularly known type of unmanned aerial vehicles or UAVs, and it is also known as unmanned aircraft systems. Drones are a type of UAV, and drones are now very much useful. Drones are now being popularly known as different applications in photography, in video recording, or in surveillance, in traffic management, and other things. Crowd management can also be done using drones, and unmanned aerial vehicles are also known as unmanned aircraft systems or UAS. So remote controlled airplanes and helicopters can also be classified as UAVs when they have particular kind of performance and remote control capabilities. So the history of drones, or you can say the history of unmanned aerial vehicles, it is started in 1918. The first pilotless radio control aircraft were used in the World War One. Okay, and the first time the U.S. Army developed this kind of drone, this kind of system as a experiment, and it is known as flying bomb aircraft. The first used drone appeared in 1935 as a full-size retooling of the de Havilland's DH-82B Queen Bee biplane. Military drones used solidified by the Israeli Air Force in 1982. Okay, in 1982, Israel started using drones. Israel started using different UAVs for military applications, for military activities. So this is brief history about the drones. Now I'm going to discuss about the types of drones. Okay, so, drones may be categorized on different categories. Drones may be categorized into different types based on their uses or based on the type of aerial platform. When we talk about the use of the drones, so on the basis of the use of drones, it may be categorized as a drone for photography purpose. Drones can also be used for aerial mapping, and drones can also be used for the surveillance. So drones may be of three types: for photography, for aerial mapping, and for surveillance on the basis of their uses. And when we talk about the type of platforms which is used for the drones, so depending on different types of platforms used for UAVs or drones, it may be categorized, it may be classified into different types, which is known as multi-rotor drones, the fixed wing drones, single rotor helicopter, or fixed wing hybrid VTOL. Okay, so these are the two broad categories of the drones depending on the uses, as well as depending on the type of platform used for that drone. And also it is important to see that it can also be categorized on the basis of the personal use or some commercial or enterprises use, but basically we use it for photography, aerial mapping, and surveillance. And depending on the aerial platform used in the drone, we may have different types of platforms. We may have different types of drones, which is known as multi-rotor drones, fixed wing drones, single rotor helicopter, or the fixed wing hybrid VTOL. Okay, so now I will discuss one by one the types of the drones based on their platforms. Okay, so as we know that drones can be categorized on the basis of different platforms. So when we are using different platforms, so it may have different names, it may have different types. So rotor is a type of drone that may include single rotor or multi-rotor type of drones. So when we talk about single rotor drones, it is having only single rotor. And when we talk about multi-rotor drones, so now this multi-rotor drone can also be categorized into different types. as it is written here: tricopter, quadcopter, hexacopter, and the octacopter. Tricopter means it is having 3 rotors. Quadcopters means it is having 4 rotors. Hexacopter it is having 6, and octocopters having 8 rotors. So in the figure you see the first figure, it is showing a drone which is known as tricopters. It is having 3 wings, it is having 3 rotors. Whereas quadcopter, this photograph is known as quadcopter because it is having 4 rotors. Then it is hexacopter having 6 rotors, 6 wings, and this is octacopter which is having 8 rotors, or we can say 8 wings. So single rotor and multi rotor are the 2 types of drones that is having used for different purposes, different applications. And single rotor and multi rotor drones having different capabilities, having different applications. In the next slides we will see what are the applications and what are the uses of different types of drones, which is categorized on the basis of their platform. So this is a drone platform, and this is one of the basic type of drone platform which is used for drones. It is having fixed wing that includes the hybrid VTOL. Means the full form of VTOL is vertical takeoff and the landing. Okay, so it is known as hybrid VTOL. Means it is used for the takeoff and landing using the same platform. And these kind of drones, which is based on the hybrid VTOL system, they doesn't require any runway. It can take off from the place where they are standing, and they can land at the same place. So they don't require any runways to start their flight. So these are very important type of drone which is known as hybrid VTOL. Then when we are talking about the multi-rotor drones, as we have already discussed, multi-rotor drones having different categories: tricopter, hectocopter, quadcopter, depending on the number of rotors or depending on the number of wings used in that platform. The multi-rotor drones are the most commonly used by the professionals and hobbyists. These are the easiest type of drones for the manufacturing, as well as they are the cheapest option available in the market. But these multi-rotor drones having some limitations. One of the important limitation which appeared in multi-rotor drones are the flying time, endurance, and the speed. Okay, and these kind of multi-rotor drones are not suitable for large scale mapping or the surveillance, because it spend a huge portion of their energy just to flight against the gravity and stabilize themselves in the air. That's why its flying time is very less. Because of the less flying time, it cannot be used for large scale aerial mapping. And it can have the capability of only 20 to 30 minutes of flight time, often with a minimum payload like a camera. Okay, so it can fly only up to 20 to 30 minutes, because it spend a huge portion of their energy just to stabilize themselves in the air against the gravity. So it cannot be used for large scale mapping, but still it is one of the most important and commonly used type of drone which is used by different professionals and hobbyists. Okay, so this is the photograph of multi-rotor drone. You can see this is a quadcopter having 4 rotors, 4 wings, and you see it is stabilized in the air. So most of its energy, most of its power is consumed during the stabilization in the air. But still, it is very commonly used in different by different professionals. Fixed wing drones, as we know that the fixed wing drones is having the rotors or wings which is fixed. They uses a wing like the normal airplane. It looks like a normal airplane, and unlike multi-rotor drones, the fixed wing type models never utilize energy to stay afloat or air. It is because of the fixed wing types, it cannot stand still on the air, and it is fighting the gravity. Okay, it takes less energy, it utilizes less energy in comparison to the multi-rotor drones, because they don't require to be stabilized because their wings are fixed. So the limitation of these kind of drones are that it is costly, and it is required to have skilled manpower so they can fly this kind of drones. It is not easy to put a fixed wing drone in the air, and it needs a runway to launch and land back to the ground. So this is having some limitation also, but still it is having larger or longer period of time, longer flight time in comparison to the multi-rotor drones. These are some of the photographs showing how this fixed wing drones looks like. You see, there are no wings, there are no rotors in these kind of drones. They are having fixed wings, and they cannot stabilize at the same place because of the fixed wings. They have to continuously move in the space. They have to continuously move in the air to capture the photographs or for the mapping purposes, and its flight time is more in comparison to the multi-rotor drones. Now I am talking about the single rotor drones. So the single rotor drones is very much similar in design and the structure to an actual helicopter. You have seen the helicopter. In helicopter, it is only having the single wing or single rotor. So it's very much similar in design and the structure like the actual helicopter. It has just one big sized rotor plus a small sized on the tail of the drone to control its heading. They are much efficient and higher flying times. Okay, because of its single rotor, it can be used for longer period of time, longer flight time, and it is having higher capacity for the mapping, and it is having longer period of time, so it can be used for large scale mapping of the terrain. But still it is having some limitations in terms of the cost. It is having higher cost, its size may be large, so we need to have skilled or trained person to control single rotor drones. It is much more complex, and it is having some operational risk during the flight of these kind of single rotor drones. So it is very important, but because of the cost, because of the large size, and the complexities and operational risks, makes it not much useful, not much applicable in the by the professionals. It can only be used by some skilled person. It can be only used by some trained professionals, so they can use these single rotor drones for large scale terrain mapping, monitoring, and other applications. So this is about the single rotor drones. So you see these are some of the photographs showing how this single rotor drones looks like. You see it's very much similar to the normal helicopter in design as well as the structure. Uh, it is having only single rotor, single wing, and a tail to stabilize to control its direction and the flight. And it may be little bit complex in terms of its design and in terms of their operation. So it is not used by the professionals normally, but it can be used for large scale mapping by trained professionals, by some skilled person. Okay. So now third type of drone are hybrid VTOL. These are kind of hybrid version of combining both the benefits of fixed wing model as well as the rotor based model. it is a it is known as hybrid drone because it is having both the functions of fixed wing models as well as the rotor based model. So because of the fixed wing model, it is having higher flying time. Okay, and with the properties of having rotor based model, it is having very much useful for stabilize at the same place. It is having a vertical lift that is used to lift the drone up to in the air from the ground, and gyros and the accelerometers work in the automated mode. That there is a concept of autopilot mode in these kind of hybrid drones. It keeps the drone stabilized in the air. So it is very much useful in comparison to the single rotor, multi-rotor drones or fixed wing drones because of its combination of having the benefits of both fixed wing as well as the rotor based system. Okay. So now it is in recently in around the world, different types of drones, different types of UAVs are used for different applications. So today we will see how these drones, how different types of UAVs can be used for different applications. So avionics in the military and scientific applications. So this is a UAV known as MQ-1 Predator. This is one of the best, you can say, this is one of the most useful UAV present in the market, or it can be used by different countries for military and scientific applications. You can see this is very much large, and it requires trained person, trained professional to control this kind of UAVs or the drones. Okay, so it has both the manned as well as the unmanned aircraft. It is focused on the unmanned aerial vehicle. It is reusable, uncrewed vehicle capable of controlled, sustained level flight and powered by a jet or a reciprocate engine. It is also known as remotely piloted vehicle (RPV) or unmanned aircraft system (UAS). For an example, R4 Global Hawk and Predator. These are two best UAVs, two best drones which is used in the military and scientific applications. It can also be used for surveillance. UAVs can also be used for surveillance purposes. It can be used for surveying. It can be used for surveying the enemy territories, the areas which is dangerous for the pilot craft. For an example, it can fly into a hurricane and provide the real-time data about the hurricanes. It can work in the extreme climates such as Antarctic. Okay, and these kind of surveillance UAVs can be used for the search and rescue operations, that can be used for search and rescue operations in the Louisiana and Texas during 2008 hurricanes. Okay, so one of the best surveillance UAV is named as RQ-4 Global Hawk. RQ-4 Global Hawk is one of the best surveillance UAV that is used by the US Army, that is used by the US Air Force for surveying, searching, and the rescue operations in case of any disaster, or in case it can also work in extreme climates. Okay, so this is the photograph of UAV, surveillance UAV, which is known as RQ-4 Global Hawk. So this is very much useful in surveying. This is very much useful for rescue operations in case of disasters, and it can be very much useful to be used in the extreme climate conditions like Antarctic. It can be used some inaccessible areas where it is, where the human cannot go for taking the data or photographs. So these are some of the specifications of RQ-4 Global Hawk. Okay, it is used for the word RQ means, R means reconnaissance and Q is unmanned aircraft system. 4 is the fourth of a series of purpose-built UAS. It is used by the US Air Force, US Navy, and NASA. It can fly at a higher altitude, and it is having long endurance. And this surveillance UAV, that is RQ-4, having a high resolution synthetic aperture radar. A high resolution synthetic aperture radar is mounted on this UAV, so it can penetrate through the cloud cover. It can penetrate through some sandstorms to capture the photographs. So it is very much useful for surveillance, as well as in case of any disaster, or in case of hurricane or bad weather conditions. It can work in bad weather condition also because of the uh, availability of high resolution synthetic aperture radar, which is mounted on this UAV. Okay, so this is the specification of RQ-4 Global Hawk. Its length is around 13.54 meter. Its wingspan, the span of the wings used in this UAV is around 35.41 meter. Its height is around 4.62 meter. Okay, its weight is around 3,851 kilograms, and it can cover 40,000 square miles area per day. So you see, it can be used for larger scale mapping. It can be used for detailed mapping. It can be used for large scale mapping over a study area, and it can cover 40,000 square miles per day. Okay, and its cost is around 35 million US dollars. Okay, so it is very costly system. It is very costly UAV, but it is having very important applications in different fields. It can have different applications in bad weather condition, for surveillance, for rescue, and other things. Combat UAVs. So combat UAVs are no are it can be used for surveying as well as attack. Okay, it is having inbuilt sensors and cameras, and missiles or other ammunition is also there in the combat UAVs. It can be used for both surveying as well as for the attack during the war. It can be used in high risk areas to hit the ground targets. Okay, but in several incidences of misfiring or misunderstanding the target. For an example, Israeli UAVs failed to differentiate between combatants and civilians, resulting to killing of 48 civilians in a war. So combat UAV is very much useful for surveying as well as the attack during the war, but in some cases there may be the possibility of misfiring or misunderstanding the target. But it can be used in high risk areas to hit the ground targets. So the one of the most useful combat UAV is MQ-1 Predator. It is having general atomics. M is multi-role. Q is the unmanned aerial vehicle. 1 is the first of a series. It is used by U.S. Air Force and CIA. It can fly up to medium altitude and having the long endurance. It can fly up to it can fly at a speed of 740 kilometers per hour, and it can fly up to 14 hours and come back. And initially it was used for surveillance only, but later it is converted to be used for combat. It can be used for attacking on the target. Its cost is approximately 40 million uh, US dollars. These are some of the specifications of MQ-1 Predator. It is a complete system. It's not just an aircraft. It is having 4 aircrafts. It is having ground control system, Predator primary satellite link, spare equipment with the crew. Its dimension is around 16.8 meter, length is around 8.22 meters. Its height is around 2.1 meters, and weight is around 512 kilograms. Okay. Space shuttles. Space shuttles can also be used for different applications. First orbital spacecraft designed for reuse, that is known as orbital vehicle or external tank. Two reusable solid rocket boosters are used for space shuttles. It can carry the different payloads to different Earth orbits. It can provide the crew rotation for the International Space Station. It can perform the servicing missions. Okay. The hardware specifications of space shuttles is written here. It is having 5 IBM AP101 central processing units. It is having same architecture as IBM System 360, and it is also known as General Purpose Computer (GPC). And it is inbuilt with I/O processor and bus system. It is having redundantly connected different subsystems. It can have bus control element for each bus, dedicated processor, master sequence control with 25th processor, and it can have display unit like cathode rays tubes that can be controlled by the special purpose computer, and it is having some mass memory unit which is known as MMU. The software architecture for space shuttle is written here. It is having system softwares that may include the flight computer OS, FCOS, system control, user interface. The application softwares can be used for the guidance, navigation, and the control. It can be used for the system management and for the vehicle checkout. So the system architecture includes the softwares, and the software may be of two types. One type of software can be used for the systems, and another type of softwares which is used for the application in case of UAVs, that is used for space shuttle. So this is the space shuttle system software. It is having flight computer OS, FCOS. It is having the management in terms of priority, queue structure, IO management. That is redundancy results in the complex data network. management of the communication. It can be used for initialization, status checks, and the memory management. It is used for the loading of general purpose computer memories, and it can also be used for transferring the memory between the mass memory and the main memory. So this is the system software architecture that is used in the space shuttles. System control software is used for initializing and configuration control of DPS. Then it can be established. It can be used for establishing the relationship among the GPCs, and the user interface for space shuttle system software having command input processing, having some operations control, output message processing, and it can be used for maintaining the communication among the GPCs. Now, these kind of space shuttles having some application softwares that can be used for the guidance, navigation, and the control. In short, it is known as GN and C. So these softwares can guide the space shuttle, uh, in, can inform about the navigation system, and can control the flight of these space shuttles. It is having 6 operation sequences that includes 200 important functions called the principal functions, and the cyclic process is there that controls the initiation and the phasing of principal functions, and it is associated with IO, that is input output kind of system, and it is table driven, and it can be used for the execution of 3 different structures in the design of guidance, navigation, and the control, which is known as GN and C. System management can be used for monitoring the status of the system, and it can control the entire system which is not involved with the flight control. Can also be used for vehicle checkout. In this process, it is used for the initialization and the checkout under control of crew. 3 ground checkouts, OPS, 1 in-flight OPS can be used, which is having some redundant computer configuration. So these are some other applications of UAVs. UAVs can be used for the mapping of areas which is affected by massive land flight. It can be used for mapping the uh, damaged crop. It can be used for mapping the infected crop and damage assessment. It can be used for large scale urban mapping and planning, and the UAVs can be used for the construction of three-dimensional terrain model. It is now very much useful in current time for traffic control and management, because most of the areas are now having the problem of high traffic. So UAVs can be used for traffic control and management, and also UAVs can perform efficient surveys for disaster prone areas where it is not possible to go physically. It can be used for providing the efficient information. It is used for providing the data sets of inaccessible areas. It can be used for quick damage assessment in case of floods and earthquakes, and that can be useful for enabling the relief measures. So these are some other applications of UAVs. It can be used in several areas with different applications, and right now UAVs are very much useful for traffic control and management in case of high traffic congestion, and also it can be used in case of any disaster, any hazards, in case of flood, earthquake, forest fire, for providing the relief and for the preparedness and other things in case of any uh, disaster. But still, there are some challenges and issues related to the use of UAVs. One of the important issue in using the UAV is the limitation of the size of study area. Then another issue is the constraint in the processing of large volume of the data, and it required a large scale processing and large storage space. So these are some of the challenges and issues which is related to the use of UAVs, but still it is very much important for different applications. And these are the challenges and issues which can be overcome, which can be rectified or sort out by using large volume data sets, by having the supercomputers that can process the large volume of the data, and it can be used for the large storage capacities. So thank you very much for today's lecture. And today we have discussed about the UAVs, the types of UAVs, different types of UAVs and their properties and characteristics. We have seen how UAVs can be used for different applications and what are the challenges and issues which comes rise during the use of UAVs. So thank you very much for today's class, and in the next class we will discuss some next topic related to the land information system. Thank you very much for today's class.